What does the setup for a somewhat rigorous self-directed AI study program look like? How do we rig up a workbench to crack open cutting-edge AI models and look inside? My name is Ram and I work at the Ethereum Foundation on internal AI ops, and this is episode 2 of an open learning journal that I'm calling the EXD. If this is your first time here and you want to know what the EXD is, you can check out episode 1 for a quick overview. But for now, on to the setup. So I basically have two machines. I have a dev machine. This is the desktop called Yoneda that I'm recording this on right now. And I have a GPU server, an AI server, which is the Gigabyte AI Top Atom. This is Gigabyte's DGX Spark implementation. It's basically a GB10 data center style GPU server. It's in a small form factor. So this is sitting on a shelf behind me. It's plugged into a wall outlet. And the goal is to keep the GPU box clean and use the dev machine to collect all the experiments, code, benchmarks, documentation, etc. The GitHub URL for this repo will be shared in the description below. And by the way, if you want to follow along and you don't have a separate machine, you can totally just replace Atom with a Docker container. Most of what I'm doing can easily be repurposed for a single machine setup. But for now, let's look at the actual machines. So this VS Code, this terminal is all running on Yoneda right now. And this is just a bog standard dev machine, nothing special about it. The AI Top Atom itself comes with a tutorial to set it up on your local Wi-Fi network as an always-on server using MDNS. So all that means is you can easily SSH into the AI Top Atom because of this SSH config. So basically set up Atom as a host. So it lets you do this basically. So you can say SSH Atom, echo OK, just to check that everything's all right, and you're fine. So this is how we are set up to communicate between Yoneda and the Atom. Let's look at Yoneda a little bit more closely. There's not much happening here. Essentially, we are sitting inside the EXD folder. That's the repo I'm going to share below. And it has a very simple structure. There's just an agents.md for my coding IDE. I use Pi currently with DeepSeek V4, which will change any moment. And two folders, episodes and projects. Episodes is basically going to contain the notes for these videos. That's what you're seeing here. And projects is where most of our work is going to live. As we go through this program, we're going to create new projects as we try to understand more. And as you can see, I already have my first project, which is just called Serve. And this is a tiny serving harness just to like deploy models on the GB, on Atom. I'll take you through this later on in the video. So that's pretty much it. We already ran this. We just to check if just a quick sanity check that Atom is alive. So yeah, let's move on to the Atom. So the Atom is basically a NVIDIA Grace Blackwell system on a chip. All that means is it has a unified memory. It's got a single pool of 128 gigs shared between CPU and GPU. And this means you can run fairly large models on this machine. So I can run the GPTOSS 120B without too much penalty. And it also comes with a custom software stack. So let's SSH in and poke around to get a better sense of this. So we SSH into the Atom. So we are now sitting inside the Atom. Now, any of you who are familiar with NVIDIA GPUs knows that this is sort of the standard invocation to see what the GPU system looks like, but you'll see here that it's actually not supported. That's because of this system on a chip configuration for this developer kit. So your standard NVIDIA SMI does not tell you much about what's going on. you know that you're on a GB10, you have CUDA version 13. This is a driver version, but there's not much else that you can see over here. A little bit of memory usage, but we don't see how much the GPU is using from your standard NVIDIA command. Instead, we'll have to use the Linux command, free memory. And you can see here that out of the 119 gigs of memory available in this 128 gigs, we're using only 3.6 right now, and we have 106 gigs free. So this will be shared, remember, between the GPU and the CPU. So when we run it later on in the video with Docker, so Docker, VLLM, and then the model itself will all occupy this space. And we have some standard swap space. So that sort of gives us a quick sense of what the GPU is working with. Let's quickly look at the CPUs. This is a lot of information, but we can just quickly look at some interesting parts. The first of which is that it uses ARM CPUs, which is becoming quite popular in the data center world. These are low power consumption CPUs, and you see that we basically have 20 CPUs in this machine. 10 of them are the Cortex 925, X925, and 10 of them are A725. And basically, it's splitting between performance CPUs and efficiency CPUs. So that's basically how they've split the workloads in the world of CPU. That's as far as the CPUs. Let's take a quick look at the operating system. So the only thing of note here is that this is actually a custom NVIDIA kernel. So that means it comes with all the drivers installed. You don't have the headache of your GPU not talking to your kernel and driver installation and everything. It works pretty much out of the box. You can see that it's basically using an ARM CPU. Lastly, let's look at Docker. So I'm going to assume that if you're interested in this subject, you know what Docker is. And basically, you can see that we don't have any containers running right now. So that was a quick run through of what the two machines look like. Essentially, we have Yoneda, the dev machine, which is going to host our most of our code and other material. And you have the GPU server itself, which is the DGX Spark with 128 gigs of unified memory. And we can actually now move on to how we get models onto this machine. So the open source world, of course, of AI lives in Hugging Face. And so what I've done is basically installed the Hugging Face CLI. Here's a simple command to do that. This is already installed on my machine, but let's run it. And basically, once you have it installed and you set up an API key, you can actually use the CLI to download models. Let's just make sure that we're logged in. And what we can do is we can list the models that we have already downloaded. So if you see this, we have got a small 7 billion parameter Qwen 2.5 model. There's the new 3.6 models. The 27B, this is a mixture of this is the dense model. And here's the 35B, it's a mixture of experts model. And we have the NVIDIA Nemotron. These are models that I've already downloaded onto the machine. And the way you download this model is quite simple. If you have the HF CLI, you basically just use the Hugging Face model name and you can quickly download the models onto the system. So this is just the simple way in which we get models onto our system. Once you download the parameters, The next question is how we serve these models. So we like to serve with VLLM. Obviously, in the local Llama space, things like Llama CPP and Olama are very popular, but we kind of want to understand what a production workload looks like more. And one of the standards out there is, of course, VLLM. That's the one we're going to play around with first. It's kind of like the entry point into production LLM serving. And because we're going to conduct many experiments and we don't want to we want to keep our environments nicely isolated, we'll run everything inside Docker. So let me just quickly give you a simple example of running a model. This is going to take some time, so I'll pause the video and resume. But this is basically a Docker command. It runs something called a container, we'll name it VLLM test, and it basically spins up the 2.7 V instruct model. So this is going to take a second to spin up. So if you see this, it's loading. So what I'll do is I'll basically pause the video and resume once it's okay. And we're back. The model should have loaded by now. So let's quickly just do a quick smoke test. We'll just curl the local host and see if we can get a response. So actually, let me just clear this first. Oh, I didn't come. Sorry. And we wanted to say hi to the model. Did not copy all of it. Here you go. So all we're saying is hi, and hopefully Quen 2.5 then responds with hello, how can I assist you today? All right. So essentially what we've done is we've got a model working on our server with inside Docker. So let's look at that. You can see that we've got the model running. It's ported to 8000 on the local on localhost, and it's working. But obviously we don't want to be running massive commands like this and then messing with them. So what I actually did was I've just created a very simple harness. So if you remember, this was our project structure, and inside the projects we have this serve project, which has some scripts and some config files. So let's look at that next. Before we do that, let me just remove this the model that's running right now. So that's called VLLM test. Oh, I forgot to say RM. There you go. So now if you look at Docker PS, nothing is running. Okay, so what we want to do is basically have a sort of a clean way of listing all our flags as configs, so that we can learn more about them. So those are stored inside the config folder, inside serve, inside project. So let's see what one of them looks like. There you go. And essentially it's just telling you which model to run, which VLLM image is appropriate for this model, some GPU parameters. We're going to learn all about this in time. And of course, any flags that we might want to add over here. So this is restricting it to a very conservative around 8K of max model length. We'll understand that later as well. And the way you run a model with this is simply by using these simple scripts. All of this again is going to be shared in the GitHub repo, so please look at it and modify as you please. But essentially, let's go into that folder. So projects, so the scripts folder. So to do the same thing as this gigantic Docker command, you can actually replace all of this with a simple /up.sh, and let's run the Quen model. This name is basically the name of the config itself. So let's say Quen 2.5 7D, and this starts the same process for you. Just simple hygiene and config driven serving of these models. Let me pause for a second here while we wait for the model to load up, and then we'll get. And we're back. Looks like Quen 2.5 has loaded up again, and let's clear this. So just like before, we would like to test if it's all working okay. So let's just quickly run the test script in the same folder, and basically the test actually asks it to explain what a transformer is in one sentence. Let's take a quick look at that actually, just so we understand. So this is test.sh, and it basically says in one sentence what is a transformer. This is what it answers. So this is just another little convenience method. And finally, to stop it, we can just run down.sh. Okay, so far we have seen what Yoneda looks like. It's just where we host our projects. We've seen how we can easily SSH into the AI top atom. And we've looked at we've sort of poked around and seen what the system looks like. It's got 128 gigs of memory. And for now, we just have a very simple way of harness for serving models set up. Now we just tested this this endpoint from the AI top atom itself, but ideally we'd like to do that from Yoneda. So that's pretty much the last part of this video. So let's look at that. Let me exit out of the AI top atom. Docker should continue to run on it. We're back in Yoneda. So what we can do is basically the GPU actually is running the AI model on its port 8000. So if we know what the host name is of Atom, you'll see that this is what it's called on the local network. So what we can do is we can run the same endpoint. In this case, we'll ask it to list what models are available. That's what the v1/models command is, using the AI top atom hostname. And this should basically give you a list of models. Let's try again. I don't know exactly what went wrong there, but there's a simple, we'll just remove the JSON tool and just look at the response directly. And you can see that the endpoint basically lists the atoms that are available for consumption. And finally, we can just run the same curl test that we ran before. Explain backpropagation in one sentence is this one. So here you go. And backpropagation is an algorithm used to efficiently compute the gradient, etc., etc. So this is basically now how we access the AI top from Yoneda, and essentially this is our workbench setup. It was kind of a whirlwind walkthrough of this very, very simple rig, frankly. We have one desktop machine, that's what I'm on now, and we've got the AI server with Hugging Face, Docker, and VLLM installed, a couple of models downloaded. So, and we served that model, and we're basically ready to start playing with the system. So that's all we had for this session. Next week, let's move on to a simple inference benchmark. Now that we have our setup and we've got a model running, let's switch to a more interesting model and start our EXD by thinking about how we can improve the performance of serving that model. See you guys then.